Assalamualaikum and hi everyone. We are from Group 9, Section 1. We'll present about the Hydrology Group Project BFC32002. So, our group member from Group 9 is, my name is Muhammad Nazar Shamid Azmin, CF220176. With my friend is Muhammad Khairul Nazmin bin Jamaluddin, CF220003. Siraj Munia bin Firdaus, CF220124. Gabriel Rajana Laki Jacob Pau, AF220125. Muhammad Akil Abzan bin Muhammad Arifin, CF220009.
Hi, my name is Muhammad Karun Azman bin Jamaluddin. My metric number is CF220003. Okay, today I would like to present about the introduction for this project. Okay, Malaysia, a country with heavy annual rainfall, is considering installing a rainwater collection system. Rainwater collecting has gained international interest recently as a sustainable home water supply according to the Malaysia government support the country national water conservation policy. Okay, for this project, we need to choose three large river that common with flood issue in Malaysia that have a nearest rainfall station via official website of Public Info Banjir. Located study. The research case study that has been chosen for Malaysia flood problem in Kapit, Sarawak. The rainfall station has been chosen in Songbi, Nagameri and Kapit Town relative to the water level at the Sungai Rajang station. Kapit is a town in Sarawak, situated on the southern bank of the Rajang River. It serves as the district headquarters for Kapit district. As of 2020, the district population was 65,800, with a land area of 15,595.6 square kilometer. So for the first picture is a rainfall station via Google Earth Pro, and the second is a water level where the located at the Kapit Town. Methodology. This chapter explains the procedure and computation utilized to solve the problem as it is presented in this project. This aims to provide an explanation of the methodology used in the study to get the precise data. We use the Department of Irrigation and Drainage DID website to collect data for rainfall and water level. We also use Google Pro to get necessary information of this station, the common flow area at the selected station, and boundaries catchment and the flow movement. For figure 1, this the ID, and for figure 2, which is Google approved apps. Rainfall and water level location study. Kapit Town, Songbi and Nagameri are the location where the rainfall data is collected. Our data on water level related to the Sungai Rajang River in Kapit Town. The main city of Kapit district, which is situated in Kapit Division, Sarawak, Malaysia, on the south bank of the Rajang River, in home to all of this station. Okay, this figure show the rainfall and water level station. First is Songbi, second is Kapit Town, and third is Nagameri.
Hi and Assalamualaikum. My name is Muhammad Akil Abzan bin Muhammad Arifin, and I'll be presenting chapter 3 second part, which is methodology. So I will be focusing about how the rainfall data or precipitation in certain area or specifically in Malaysia is collected. So rainfall data is collected using various instruments and methods. There are a lot of instruments. We can choose to collect the rainfall data. There are some common ways that often used in Malaysia specifically. So firstly, rain gauge. Rain gauge is often used in everywhere. There are a lot of cases where rain gauges is preferred compared to others instrument to collect precipitation data. So there are two types of rain gauges. So firstly, there is standard rain gauges that are simply a cylindrical containers with a funnel at the top to collect direct rainfall into a label and graduated measuring tube. The amount of rainfall is measured by reading the water level in the tube fall. And so there also the second type of rain gauges, which is tipping bucket rain gauges. This is the old ways to collect the data without using much technology reliant, and it is also accurate. These gauges have a funnel that directs rainfall into a small bucket. When a certain amount of water is collected, the bucket tips over and the amount of tipping event is counted electronically, which only use a pen and motor hand arm. Each tip typically represent a small known amount of rainfall, and that is second type, which is weighting gauges or float type. These gauges have a container placed in a scale. As rainfall collects in the container, it increases the weight is recorded, providing a measured amount of rainfall. There also the other one that is uncommonly used in collecting rainfall data is using float type, which is dependent on atmosphere and humidity of the surrounding area. So from the precipitation data we collected, so what is the use of the precipitation data we collected from stations to stations across various areas in Malaysia? So the rainfall gauge or precipitation data we collected by using gauges is contributing to we calculate the mean precipitation or average precipitation of the area. So there are a lot of calculation method to approach this problem or this situation. So there are polygon Thiessen, there is associated method, and there is the normal average calculation by using stations nearby. So polygon Thiessen calculate the specific area that we want to calculate, or the catchment area, in order to get the average rainfall data across the highlighted or area shown. Meanwhile, the associated method, we calculate the average data by using the isoiot lines, which we construct by looking at the data we get from the gauges or stations. So what happen if the rain gauge or the station undergo maintenance or having troubles in certain period of time? So we can approach this problem by using the double mass curve method to identify or to obtain the missing data to able to use it for other calculation method to find the average rainfall. This is often used in hydrograph in Malaysia. Hydrograph in Malaysia is shown to public and shared by the Jabatan Air, if I'm not mistaken. It is shared to us for public use. So the Malaysia government also obtain data by using this type of collection of data from stations in the Malaysia. So for the second part of my presentation, which is data presentation, comprehends from how we find or we tabulate the data from the website. The website is from Infobanje, which is very useful for researchers and to alert residents in the area about flash flood or flood in general, natural disaster that revolve around precipitation or rainfall. So there are 3 stations we choose to collect the rainfall data of 1 month period. So the station is Kapit Town, Songbi, and Nagamarit. This station is nicely spread out in a shape for the catchment area, for we able to find the mean area of precipitation in the catchment area. So the water level data, we are going to monitor one station, which is Kapit Town. So from these 2 hydrograph we obtain from the website, we can do analysis, and hence we will provide the average precipitation of the area by using, or approach it by using various method. Okay, that's all from me. Thank you.
Assalamualaikum and selamat sejahtera to Doktor. I'm Siraj Munir bin Firdaus and my matrix number is CF220124. So right now I'm going to present to you on the chapter 4, which is data analysis. First thing first, we'll take a look on the mean rainfall data. So I'm selecting from the 11th until 17th of October 2022 as the data to calculate from the 3 months of the data we have collected. Okay, so let's take a look to the total of the mean rainfall we've got, which is 9.5 mm for the Kapit Town and 11.0 for the Songbi, and also Nangamari is 25.5 mm mean rainfall, total mean rainfall. Okay, so next we have to calculate for the arithmetic mean method, which is, we can see here, P is average precipitation depth in mm, Pi for the precipitation depth at gauge with the topography basin in mm, and also the N, the total number of gauging stations within the topography basin. So basically we have to sum up of the total mean rainfall we've got from the 3 stations, and then we have to divide it by 3, and then we've got 14 millimeter as per you can see at the slide. Next up, we go through to the Tyson polygon method. So as you can see on the slide below, there is the catchment area for the Tyson polygon method that we've got, and we can see the area for the capital is 643 meter square. For the zombie is 844 meter square, and also for the Nangamari is 653 meter square. And then we got the precipitation as the slide before, and then we have to calculate the area x precipitation. Oh, sorry, area times precipitation. Yeah. And then we've got as per data below, and as you can see on the table. And then we have to calculate the average of the precipitation depth. So to calculate this, we have to divide it the total area times with precipitation and divided by the total area, and then we've got 13.75 millimeter. Next, we go through to the isohydrate method. So this is the catchment area for this method that we've got, that we sketch. So we go through to the table below, the isohydrate interval in mm. Then the first one, 10 to 13 mm. And then we have to find the average precipitation, which is 10 plus by 13 and then divided by 2, and we got the 11.5. This is referring to the zombie session. Yeah. and it goes same way for the next two station. We have to plus the two isolated interval and then we have to divide it by 2. And then the area, we got 405, 339, and 360. And then the next table is the area times with the average precipitation in mm squared. Okay. And then lastly, we have to calculate the average precipitation which is in mm. So how to find this? We have to divide the total area times average of precipitation and the divided by the total area. Yep. And then we've got 13.00 mm. Okay, so before we go through to the water level data, we have to know how the formula how to calculate the hydrograph. So you can see on below here, Q is for total flow, A is for cross-sectional area of the stream, P for the weighted perimeter of the channel, R is the hydraulic radius in meter, and N is meaning roughness coefficient of the channel, which is we are using 0.15, and the slope is 0.05, and B is for the width of rectangular, and A for the area. So how to find Q? We can also use the AV equation or the other equation, which is 1 over n, which is n is the meaning roughness, times with the A area with the power of 2 over 3, times with the slope with the power of 1 over 2. Okay. And how to find the V? As below, V is for the velocity, which is 1 over n, and again n is the meaning roughness, times with R, which is hydraulic radius that come with power 2 over 3, and times with S, slope with the power of 1 over 2. Okay, and you can see the complete table data on the next slide below for the week 1, week 2, week 3, and week 4. So that's it from me. Thank you and assalamualaikum.
Okay, so after we find the our mean rainfall, and we got the mean arithmetic mean method and the decent polygon and the isohydral method. Then next we calculate the water level data. So that we use the formula to calculate hydrograph. Okay, so the next step is data analysis for cross section profile. So what we going to do in this cross section profile? So we will use a Google Map to find the perimeter and the area of the cross section upstream, the middle, and then the downstream. So if you look at the first image right here, this will be the upstream of the cross section, and then the top here is the middle cross section at middle, and then down there is the cross section for downstream. Okay, so for the cross section for the upstream, we find the perimeter. Perimeter is about 658 meter, and then the area 458. So then we got the slope, and then find the n, and then the r, a over p. We use the formula, and then we got for the q. Okay, so when we got the q, so that is the cross section at upstream. Okay, the next one is cross section at middle. Okay, so you use the same method there to find the q value for the cross section at middle. So the third one is cross section for downstream. We use the same method again. We use the same formula, find the perimeter area and then the slope. Then we got the q value. So that's it. Okay, so next we're going to look at the next data analysis of the rational method. Okay, so after we got the cross-section profile, so we used the rational method to determine the rainfall intensity,
using empirical IDF curve based on the MSMA edition, second edition. So what we know for the I is the average rainfall density millimeter per hour, and then the T is the average recurrence interval, okay, RI. Okay, so that means like a 0.5 T 12 months, okay, and then the D is for the storm duration hours, you can say month about 6 years, okay, and then the lambda K, and then the N is the feeding constants dependent on the rain gauge location. Okay, so this one basically we can get it from uh, the MSMA second edition. They already provide the value for the N, K, and then the lambda. Okay, so first we find the ratio method we use for the three types of location, which is the location Nanga merit. So we find the location Nanga merit, we find the value from the table, and then we got it. So find the QP, the the precipitation, okay, meter cube per second. Then we got the value. Then we find for location Capri, and then we got the value, and then location sound. Okay, so this sound, so these three location we find, we get the QP, meter cube per second. Okay, so after that we go for the next one is hydrograph and linear hydrograph. So hydrograph we use to find to show the rate of the flow, this is time, canal or other conduct carrying a flow at a specific point. Okay, common units for measurement for flow are cubic meter, cubic feet per second, okay, or cubic meter per second. Okay, so we do for the hydrograph for the cross section one, and then the unique hydrograph for the cross section one, and then we go on to the cross section two and the cross section three. So we find the hydrograph, use the profile. First, we find the total flow versus time, and then for the unique hydrograph, we use the ordinate runoff versus time. So then we use for the cross section two, and the same goes to cross section three. So after that, we finally got our unit hydrograph and hydrograph. Okay, so we got our graph.
And now we go to the discussion. Malaysia is classified as having a tropical climate on the Climate Change Coalition portal with an average annual temperature is 25.4 Celsius. So in the average monthly precipitation is of 200 millimeter in June and July of 350 millimeter in November and December. So the level data offer important insights into the hydrological dynamic and of nation, providing data that is essential for disaster preparedness. Environmental sustainability and management of water resource is important to Malaysia's varied rainfall pattern which impact to my monsoons and geographic variance in emphasis in paper. And now we go to the conclusion. This study concluded by contrasting and comparing several methods of figuring out runoff output for drainage design. So, numerous hydrological techniques can be used to determine the peak flows and a catchment region, with the technique suitable for every catchment area. The unihydrograph technique is not the frequently used to lead to the limitation, which include the cost of obtaining runoff data for a given catchment and the lack of runoff data at least 35 years. So we can estimate all the approach studied, even though it is a estimate. The design storm peak discharge is often predicted using the rational formula.